11.6 compute the volume of the following solids. First, the solid generated when the ellipse x squared over a squared plus y squared over b squared, which is this. Okay, so this is b and minus b, and this is a and minus a, and this is the ellipse, right? Now if it rotates around the x-axis, we get this ellipsoid, right? Now it's clear from the symmetry that we need to just consider the rotation of let's see, this is, if we consider only this part of the ellipse, right, in the first quadrant you get half the volume, right? So the volume is going to be twice this volume, which is, and now we have the integral between 0 and a of pi, right, and then this f squared, but this f, we have this, we can solve the y, right? So we have y is equal to b times the square root of 1 minus x squared over a squared, right? So we need b squared and then 1 minus x squared over a squared, right? This is our y equals f of x as the curve, right? Okay, so we have here's 2 pi b squared, we have x minus, and this is x cubed over 3a squared between a and 0, right? So this is yeah, when this is 0, this is 0, so this is just 2 pi b squared, a minus a cube over a squared is a over 3, so this is 2 over 2/3 of a, right? So 4/3 of pi b squared a. Okay, now it's interesting because if b and a are the same, right, that means we have a circle, we get the area of the sphere back again. The same thing on the y-axis, we have again y is b times the square root of 1 minus x squared over a squared, and now we have the volume here is this 2 pi times the integral between, in this case again, 0 and a, right, of, sorry, 2 times this, right? Let me, if we have this and we rotate it around this axis, right, we get half of the volume, so 2 times that, 2 pi, the formula for this is 2 pi x, and then times the formula f of x, right? So this is b1 minus x squared over a squared dx. Okay, now we can write this as 1 minus x squared over a squared to the 1/2, right? And so the integral of this is going to be, we have here, this is something like the derivative of this, right, with a minus on top. So we can say this, let's see, this is 4 pi, right? And if we differentiate this, right, we have let's see, this is minus 2x over a squared, right? So we have here minus 2x over a squared, we have to multiply by minus 2, sorry, divide by 2, minus, divide by minus 2 and multiply by a squared, which is from 0 to a, right? This is the derivative of this, but we have to take into account that you also have the 3/2 when you differentiate this, right? If it was the 3/2 here in this exponent, you have 3/2, right? So you have to multiply by 2 again and divide by 3, so you have 3 and 2. Okay, now this, all of this is the derivative of 1 minus x squared over a squared to the 3/2, right? And we have to evaluate it between 0 and a. At a, this is 0, right, because this is 1 minus 1, so at 0 we have that 0 is 1, so the area here is and I forgot a b, sorry, around here. Okay, we have a b, right, so we have and at 0 this is minus 1, sorry, so this is 4 pi b a squared over 3, okay, which is, as you can see, symmetrical to the part I, right? In part 1 we had b squared a, now we have b times a squared. And again, if b and a are the same, we have the volume of a sphere. Now finally 3, the solid whose base is the ellipse above, so let's try to paint it somehow, right? This is, suppose this is the x-axis, this is our point A, this is our point minus A, right? This is the ellipse, this is our y-axis, this is B, this is, or minus B, this is B, and now we have our z-axis. And so at each point we are having something that is a triangle here, right? And so I don't know how to paint this, but it must be something like this, okay? So at each point it looks like a tent somehow, right? And so you have the section here, which is, I think you have to, the volume of this, right, is going to be the integral between minus a to a of the area as a function of the point x dx, right? And the area of this triangle, let me paint it more accurately. This is an isosceles triangle, and so the height of this triangle is 2, and the basis, or the base of this triangle is, this is minus y, and this is y, right? This the triangle goes to, and so this is, the basis is 2y, so the area here is 2 times 2y divided by 2, right? This is the area of the triangle, base times the height over 2. So this is just 2y, and y, remember, was b times the square root of 1 minus x squared over a squared. So this is the integral between a and b, and sorry, minus a of 2b, the square root of 1 minus x squared over a squared. Now this is one of those integrals in which we have the square root of 1 minus something squared. We have to write x equals a times the sine of theta, or x over a is the sine of theta, so that the square root of 1 minus x squared over a squared is the cosine of theta. And so we have dx is a times the cosine of theta. And now we have 2b. The integral, when x goes to minus a, that means the sine of theta is minus 1, that means theta is minus pi over 2, and pi over 2 when x is equal to a. This is the cosine squared of theta. There's an extra a here that goes out, and the theta. And now we have to integrate this. So remember that this is 2ba, and then we have the integral between minus pi over 2 and pi over 2 of 1 plus the cosine of 2 theta divided by 2 d theta. 2ba times theta halves plus the sine of 2 theta divided by 4 between pi halves and minus pi halves. Right, so let's see. This is the sine of 2 pi halves is the sine of pi, which is 0, tan of this is 0, right? And so we have pi halves over 2 is pi over 4, minus pi over 4 is pi over 2, times 2 is pi. So the result is pi times b a. That's the volume of this kind of tent